Okay, question 23. We are doing another question that's going to entail the formula R equals L times K divided by CMA. This time we are, and this is a good habit to get into, we're looking for the length. So writing down the value that we're looking for. And also the values that we know. So we know we're dealing with copper, so we know the resistivity of copper is 10.4. We can mark that down. So we know K, we know the CMA is equal to 8,220. And we know that the resistance is equal to 33. And one thing that's good to get into the habit of is looking at the question and being able to recognize or hypothesize what the answer is going to be approximately. So if we're dealing with a conductor and its internal resistance is going to be 33 ohms, so that's a pretty large number. And so we know that this length of the resistance of the conductor, is going to be very, very large to be able to produce a resistance that high. I mean, if we're dealing with copper, copper is very it conducts it very, very well. It doesn't have much internal resistance, so must be a very long piece of conductor or copper conductor. So we know it's going to be high. Now, one thing we got to do here to solve this formula is transpose this formula. So one thing, what I would do is I want to isolate L on this side of the formula. So to do that, all we got to do is bring the K to the bottom side of this formula, from the bottom side of this equation, and we'll bring the CMA from the bottom to the top of the other side of the equation. So that's going to leave us with L equals R times CMA divided by K. And so we need to be really familiar with being able to transpose a formula like that in leading into our finals and definitely in subsequent years as well in the electrical trade. Transposition is pretty vital. So now it's just a matter of filling in our values that we know. So 33 times 8,220 divided by 10.4, which is going to give us a length in feet of 26,083. And so, like we hypothesized, the length is going to be very large, and the answer is D.